first question is proving the distance from S dash Q plus QS is bigger than the distance from S dash R to the RS. Okay, so what does that mean? The question actually asks you proving. So the distance from S dash to the S via the point on the tangent will be always bigger than the distance from S dash to the S via the point on the ellipse. This is what I asked you proving. So how do we going to proving this? So let's go. So first question is, my left hand side is equals to S dash Q plus QS. And then I can split S dash Q into S dash R plus RQ, then plus QS. And then we know the triangle inequality properties, the sum of any two sides would be bigger than the third side. So I can say this RQ plus QS is always bigger than the RS, triangle inequality properties, right? So then what does that mean? Meaning this distance plus, I think I write RQ plus QS, this should be Q, yeah, QS. This is plus this distance will be always bigger than RS. And then I still have S dash R in here. So then I have this proved. This is because this is the right hand side. So I'm gonna repeat the result. Tells you the distance from S dash to the S via the point on the tangent, for example Q or any other point, will be always bigger than the distance from S dash to S via the point on the ellipse, for example R. So that's the result. So now let's do the second question. Second question is proving the distance from S dash to S via the point on the tangent, for example Q, will be bigger than the distance from S dash to the S via the point P. Why this is bigger than the distance via the point P? Because P is a point on the tangent, and also P is a point on the ellipse. So distance from the P dash to the, from S dash to S via the point on the ellipse is always less than distance from S dash to S via the point on the tangent, right? So from the previous result, we can say S dash Q plus QS will be always bigger than S dash P plus PS, as we know P is on the ellipse. P is on the ellipse, therefore we have this distance bigger than distance. So then, because P is the only point is on the ellipse but also is on the tangent. P is the only point on the tangent but on the ellipse. So any other point on the tangent, the distance will be always bigger than the distance via the P. For example, this point to that distance will be always bigger than the distance from S dash to P and P to S, because P is on the tangent and also on the ellipse. So therefore, we proved the distance from S dash to S passing through a point on the tangent is through the P is having the shortest distance. S dash P plus PS is the shortest distance. So we proved. Now let's prove in the question 3. So proving question 3, I'm going to join the PS star and also QS star. So I'm going to proving this triangle is congruent to this triangle. But it's very easy to prove they're congruent. Then we can see S star, I label this point is A. It's easy for me to do. So S star A is equals to SA, that's by constructing, and also we have PA is perpendicular to S star S. So this gives us right angle triangle here. And also we have PA is common. So then we can say triangle PAS star is congruent to triangle PAS is really is SAS. So prove congruent. So therefore we can say PS star is equals to PS. So then similarly, we can also prove in triangle QAS star is congruent to triangle QAS. Same reason SAS. Then we can say therefore QS star is also equals to QS. So with these two results, I'm going to highlight these two results. One is this equal to this, and another one I using these colors. This equal to that. Okay. So now how does this help me to proving the next questions here? So we know we have previously S dash P plus PS is shortest distance pass from S dash to S. Then which means S dash P plus PS star is also shortest. Compared to, because we're using the PS dash star equal to PS. Therefore, this is also shortest. And then what does that mean? Means we have S dash Q plus QS is bigger than S dash P plus PS. We had it before question 2. From question 2, we have that before. So what does that mean? Meaning, since we have this is equal to this, so we have S dash Q plus QS star is bigger than the S dash P plus PS star. We have this sentence. So this sentence tells us a very important result. What does it mean? Meaning the distance from S dash to the S star, from this to here, if I the point Q, that will be longer than the distance from S dash to the S star by the P. This distance is shortest distance. Compared to any other point on the tangent apart from P, they will be always bigger than that this distance. So meaning this distance is shortest distance, and the shortest distance meaning is a straight line. So from here we can say therefore S dash P S star is straight line. So then we can say, therefore, angle S star PA is equal to angle QPS apostrophe. Why? Since we say this is a straight line here, and we know this is also straight line, so then this angle, of course, equal that angle. They're vertically opposite angles. So we spend question 1 and question try to prove this straight line, then give us vertically opposite angle. Then the next step I can say, and also because angle S star P A is equal to angle SPA. That's from congruent triangle. Remember, we have these two triangles was congruent triangles. So then we can say this angle is also equals to, this angle is also equal to this angle. Corresponding angle in congruent triangles are equal. So then from here, then we can say, therefore, angle QPS apostrophe is equal to angle TPS, which means these two angles are equal. That's the proving of the reflection properties. Done.